Okay, good afternoon, everyone. Madam, can you hear me?
Yes, we can hear you.
Okay, we have some reasonable number of people now that have actually joined. At least we'll have about 24, 25 coming in right away. So I think we need to start because we don't have much of our time to waste. We want to welcome every one of us that have joined us in this webinar series. This is the third one we are conducting this year by IAMESEP. We've been able to carry out entrepreneurial opportunities in mineral and mining sector during our first presentation for the year, January, which was done by Dr. Blaya Muda. And February, we were able to discuss one of the issues affecting women lives and livelihood in ASM community, opportunities and reforms, which was actually presented by one of our guest speaker, Emilia Fodile. And today, the third in the series, within this year, March, we'll be presenting an interesting topic that is very, very critical in the mineral mining sector, which is mineral testing. Mineral testing, the suitable techniques for critical metals and industrial deposits. This will actually be carried out today by one of our also guest speakers who is very versatile and have a lot of field experience, Mr. Christopher. And next month also, I will also want to introduce the topic, which is we'll be dealing on the local ore processing techniques, the way forward in Nigerian mining sector. This will be actually carried out by also one of well-experienced mining engineer, Michael Okoto. So I think—
Another one.
Yes. So I think we have so much. I will list all of them now, but we have so much interesting topic to discuss and have a way forward within this year. We'll be talking several things, cutting across mining, cutting across exploration, cutting across gold sampling methodologies, the market studies, and some of the key indices. We'll be talking some things across the ASM and their way of working, talking something on pollutions and environment, on community consent and CDA also. We want to also touch that. So these are all the things we want to be dealing with within the IAMESEP webinar series for the year 2022. And for most of us that have joined up for the first time, we are actually a non-governmental organization. IAMESEP stands for Initiative for Advancement of Mining, Earth Sciences, and Environmental Protection. And we actually deal with some of the mineral-related and mining issues with some special interest in the area of artisanal and small-scale mining activities in Nigeria. And also, our value proposition is just meant to bring sanity within the circle of ASM, to maximize the economic benefits associated with mining activities within the states. This is, in other words, we try to reach out to restructure informal miners and their crude way of activities to also enhance the technical know-how and formalize their activities to achieve, and also further put various environmental and socioeconomic sustainability tools to maintain a healthy environment. So with this, we've actually tried to put in some projects or some vehicles and processes in place in order to carry out some of these things.
The minerals around you. There are so many minerals that we have used as tailings in those days, and up till now, we have not known how to differentiate one mineral from the other, especially for those who are really doing the little mining in the field. I mean the artisanal and small scale miners. You can see in recent times, the Chinese will come to the site. They won't even ask us of how we're exploring this mineral. They are after the tailings. And then we think that they are helping us with environmental remediation and the rest of it. And that's how they made their own money. But if we should know what we have on ground and what we have at hand, using different techniques to test it, even on the field, I guess it will be a long way. It will go a long way for us to be able to achieve the maximum benefits of our minerals in any, as a small scale miner or a large scale miner. I believe that there's nothing useless in the mines field. There is nothing. It's just because we don't know the usage or the mineral composition. That's what made us to feel that one is not necessary. The other one is what you are looking for. Each time you are looking for any of those minerals, please take cognizance of others. It might not be useful today, but for sure, the future speaks a lot about this. You can see now today, we talk about different rare element methods that are now in vogue. Most of us have thrown this away as waste in the past. So today's lecture is about this, how to take us to the next height in the process of mineral beneficiation and value addition.
Thank you very much. Thank you very much for that opening remark. I will want to emphasize mainly on the objective of our today's presentation. We've deemed it fit to understand that at the end of the day, at least we should be talking about understanding what generally the mineral testing is all about. We will also try to differentiate between the critical metals and the industrial metals. This is very, very important. Why we are trying to focus on these metals is because of their irreplaceable and their high supply risk, because of some geological issues surrounding these minerals exploration and technologies. So also we will be able to assess the various techniques that are actually available in mineral testing. And also we'll be able to assess the suitable techniques for assessing the concentrations of some of these critical metals and the industrial deposits and all that. So I think we will also understand generally, when to test, what is required to test the right mineral, especially for some of these values of these ores. We normally, we actually mine every day in Nigeria. Unfortunately, we don't have most of our labs here. We're having issues with some testing locally. Most of our testings are actually being done abroad. This is one of the ways we are trying to advocate for some of the standard labs to actually see how we can put them on here. Today we will be hearing from Christopher Uyime-Ebong. Christopher Uyime is an experienced mining laboratory quality assurance chemist with a demonstrated history of work, experience in chemical laboratories, mining and metal industries. He is also experienced in water treatment plants and ammonia urea production plant also. He's also a skilled personnel in terms of sampling and pre-treatment and wet chemistry of various minerals, including the lithium ores, including the zinc ores, the iron ores, the copper ores, the manganese ores, the bauxites, limestone, dolomite, quartzite, quick limes, and all that. And He's also a proficient in the use of analytical instrumentations, the UVs and the VIS, and also the spectrophotometers of ASC and SEM XRD EADS. So these are all, I think, we can, he's actually experienced with, and today we want to hear from him and actually ask our various questions containing some of these techniques and standards. So you can see he's a field person, highly experienced, and also working one of the biggest mining company right now in Nigeria in terms of lead and zinc, and also in the processing of these concentrates. So I think it's right time we bring on board our guest speaker today. At the end of the day, please, when the presentation is going on, if you have any question if it's going on, you can put it down and you can send it through text. We can look at it. If you have any contribution also, at the end of the day, we can actually do that. We just have about 30, 40, 45 minutes for our presenter to do due diligence to some of these, to this topic. So right now, I want to make welcome of our guest speaker, Christopher. Christopher, are you on board, please?
Mineral testing and a suitable technique for critical metals and industrial deposits. Please give me the next slide. Nigeria, generally, Africa in general, is blessed with a lot of mineral resources, ranging from gold, iron, lithium, any of the mineral resources you can think of. Africa generally is blessed, and Nigeria is not left behind. You can see almost all the minerals or all the elements or all the metals is present in Nigeria. The only challenge we are having currently is because we don't have a suitable technique for us to be able to assess or quantify the availability or the value of these metals. Nigeria is blessed with almost all the metals as we talk as you can see. And you can see that these metals also, they are scarce. They are becoming scarce almost every day because, in fact, you know what is going on in Nigeria now or in Africa. Every day we keep on taking up these ores. We take on offsetting the balance of the ore. So the metals are getting scarce. But for us to, with the little ones that are available, for us to be able to have a value for it, then we need a suitable testing technique that can be able to determine these metals in their concentration, or we can able to have a value for this ore. So it's very, very important. There are a lot of ways that these techniques can also are being misused. There are a lot of techniques in the market that can be used for the determination of both critical elements or critical metals and industrial deposits. There are a lot of elements in the market, but the problem is that a lot of these techniques are misused because you are using AS. You think that AS can atomic absorption spectrophotometer can analyze all the elements. No, it's not like that. Or maybe you are using XRF. You think that any metal or any metal deposit that you can use XRF to get the value. It's not always like that. So most times these techniques are not suitable for a particular mineral analysis, but because we don't have the information, or maybe we don't have the knowledge, or we don't have the funds for us to get the right instrument for that particular metal analysis, we just use anyone we like. So I think before the end of this program, we'll be able to understand the suitable techniques that can be applied for almost all the metal values that we have in the world or in Nigeria in general. So there are different instruments that are out there that can produce great results. Okay, but also at the same time, this instrument also, because they are instruments, just like we normally say that computer is garbage in, garbage out. So they are also instruments. So that's why the fact that they can produce a good result or a good report, they can at the same time misuse. And once they are being misused, a wrong result is also obtainable. So please, the next slide, please. So at the end of this program, we should be able to understand what mineral test is all about. And please mind you, when I'm talking about mineral test, I'm not talking about mineral profiling. That mineral profiling is in the food industry. So we are not talking about mineral profiling. When I'm talking about mineral, in any situation you hear me mentioning mineral, just know that I'm talking about ore body, value ore. Okay, so it's not mineral profiling in the food industry. So we're going to understand what mineral test is all about. And also we are going to also differentiate between critical metals and industrial deposits. And we're also going to assess the various techniques that are available in the mineral testing industry. So we're going to assess all the various techniques. And then after you have assessed the various techniques, we are also going to look at the suitable techniques. It's not enough for you to know the various techniques. Which of the techniques is suitable for that particular ore or for that particular mineral that you want to check? So at the end of this program, we're able to understand the 4 pedestals of this program. Thank you. Next slide. All right. So what is mineral testing? Okay. Mineral testing, or sometimes they also call it mineralogical analysis, is a study of minerals, okay, or study of ores. To determine, there are 2 things about, all right, that we do mineral testing, to determine their composition and their structure. Okay, so those are the most important aspects of mineral analysis or mineral testing. We want to understand what is this mineral, what is it composed of, what is it made of. For example, they give you a stone. Do you know that in some countries, gravel is a valued ore? Okay, so if they give you a stone or they give you any solid mineral, you should be able to, understand the composition of that mineral, and you cannot understand its composition with just looking at it with your eyes visually. No, you don't get the composition of minerals visually. There are a lot of chemical, physical techniques that have been applied for us to, definitely understand the composition of the mineral ore, and sometimes also the structure. Yeah, I'm going to bring you to XRD. With XRD, we're able to understand the mineral species or the structure of the mineral ore. So the important aspect of the mineral testing for us is used to identify mineral species, also elemental compositions, and then understand their characteristics and properties. That is, in characteristics and properties is in terms of research. Those that are in the institution of learning, you can also use mineral testing for you to understand the characteristics of the particular mineral or at the same time the properties. Currently, I'm working on a sediment sample for one of my postgraduate studies. I'm working on a sediment sample that I'm going to use XRD for me to study the characteristics and the properties. So you can see that mineral testing is very, very important as long as mineral industry is concerned. And it's not only for the chemists that do the analysis. No, mineral testing techniques should be understood by everybody in the mineral sector, including the geologists, including the chemical engineers in the mining sector, including mining professionals, even artisanal miners, and even those that are trading. You that is buying and selling of ore, you also need to understand what mineral testing is all about. We're going to see that to progress in the course of this study. Thank you very much. Please, the next slide. I'm trying to meet up time. I hope I'm not too fast, please.
No, I'm fine.
Oh, good. Okay, please, if I'm too fast, just okay, thank you. Now, this is a periodic table for those that are chemists, even geologists too. Every metal or every ore, they have an element that can be traced down to the periodic table. All right, the periodic table shows us the physical and the chemical properties of an element. So every element, any element you can think about. For example, now we are in the lithium rush. Everybody is now buying lithium. Like, for example, you take for spodumene or amblygonite or any of the lepidolite, any of the lithium, or you can trace it back to lithium. For example, you take galena, which is lead ore. You can go back, you can trace it in lead. Or you take sphalerite, which is zinc ore. You can also trace. So every ore is traced back to the periodic table. So understanding the properties of the periodic table also helps you in understanding the suitable techniques that can be used in the analysis. Like when we're in school, those days, maybe in the university, they told you that all elements in the periodic table that are in the same group have what? The same chemical properties. So that is the basis. All elements in the same group in the periodic table. Look at hydrogen. Hydrogen is the first element. Look at the group of hydrogen. The last one there is francium. The properties of hydrogen and francium, they are similar. So if you can study the property of hydrogen, you can also study the property. Look at the last group of the beryllium there, radium. They have almost similar properties. So understanding the properties of this element or the group in which this element belongs, you want to understand the group, you'll be able to assign a suitable technique that can be used to analyze your metal of interest. Are you getting it? So it's not just getting a metal analyzed. First of all, just as I said, the mineral testing has to do with understanding the composition, the structure, and the characteristics and properties. So the characteristics of the metals are gotten from the periodic table. Okay, the same way I'm going to analyze lithium ore is not the same way I'm going to analyze for gold. Never. Why? Because their properties in the periodic table are different. So if I'm going to use an instrument that analyzes lithium, and you think that I'm also going to use the same method or the same procedure to analyze gold, that I'm going to get an accurate result or a precise result, you are wrong. Because gold and lithium, they are in 2 different groups in the periodic table. We are talking about suitable metals rather, or techniques that can be used to assess the value of critical metals and or the industrial deposits or industrial minerals, as the case may be. For some of us that does not understand or does not know when we're talking about critical metal, what it means, I just give an highlight of what critical metals is all about, so that once you hear the word critical metals, you should be able to understand what the word is. Just a critical metal, just from the name, critical. All right, critical is very, very scarce. From the word critical, is very scarce, and it's a very important economic value in the world. Almost every continent of the world, they are looking for these critical metals in different places, and Africa is blessed with them. So what is it all about? It said that they describe critical minerals as metals and non-metals that are considered vital for the economic well-being of the world's major and emerging economies. Yet, whose supply may be at risk due to geological scarcity. This is very important. Why? That is why it's called critical metals. All right, the supply may be due to geological scarcity because it's not available in every place in the world. All right, so there are geological locations that are available, and also geopolitical issues also may make it critical. Maybe there is a war or a communal clash between two communities, so that can also make a particular metal critical. And also trade policy or other factors can also render a particular metal as a critical element or critical metals, as the case may be. Among these important minerals are metals and clean metals used in the manufacture of mobile phones, flat screen monitors, wind turbines, electric cars. We are going to talk about lithium, solar panels, and many other high-tech applications. So you can see that critical metals are very, very important in the industry. In the 21st century, it's very, very important. We are going to look at example next slide so that we can see examples of critical metals, so that you can, if you see a critical metal, you're able to know that this is a critical metal. Please, next slide. Let's see the examples of the critical metals. All right, you can see that the rare earth elements, if I was the one projecting, I could have shown the periodic table, but at the moment, Mr. Gideon is helping us with that. So the rare earth elements, we can see gallium, indium, tungsten, okay, platinum group elements, we call them PGE, are also including platinum, okay. You can see the rare earth elements there. The lanthanide and the actinide series are also considered to be the rare earth elements. All these elements are seen from lanthanum, okay, down to laurentium. That is 187 down to 103 are termed as critical metals. Please back to the slide. Thank you. They are called critical metals. All right, and also the platinum group. If you can look at the periodic table again, you see platinum at platinum 78, atomic number 78. Okay. So all the elements in the platinum group also are also called critical metals. We have the cobalt, niobium, magnesium, and the rest of them, including the tantalum that everybody is looking for in Nasarawa and Adamawa, is also a critical metal. Even lithium, in the lithium rush, so lithium can also be classified as critical metals due to its geological scarcity and also the zone. So lithium also is also part of that. And also the rare earth metals, okay, I've talked about that. So please, the next slide. So we all understood what critical metal is all about. Let's move on to industrial deposits. What is industrial deposits? Next slide, please. All right, so industrial deposits are geological materials which are mined for their commercial value and are not sources of metal. Please, I'm going to tell you what this means. They are mined for their commercial value, but this industrial deposits, they are not sources of metal. You can't get metal from them. For example, let's take for limestone, for example. Limestone is an industrial deposit or is an industrial metal. You cannot take calcium from calcium carbonate. The mineral component of limestone is calcium carbonate, but you cannot extract calcium from calcium carbonate. No way. There's no technology that can be able to do that. Okay. We also have a lot of them. We have talc. We have a lot of them, which I'm going to show you. We also have diamond. We also have graphite. All these ones are feldspar. Okay. Feldspar also among industrial deposits. They are not source of metals, but they are used for their commercial value, okay, but I also use industry based on their physical and chemical properties, like barite. You know about barite? I think last some weeks ago, I did an analysis on barite for some oil companies, Clobenja. They use it for drilling, for their marine drilling, and as the case may be. So those are industrial deposits. So you are able to distinguish between what critical metals is all about and what industrial deposits is all about. So industrial deposits are not metals, unlike critical metals. Industrial deposits are just ores on its own, which can be mined, but the only which can be mined, sometimes beneficiation. Okay, we can also beneficiate them to bring out the metal content from them, but the metal content cannot come out pure. Like if you are beneficiating lead, like galena is lead sulfide. If you are beneficiating it, it cannot bring out pure lead. You can only beneficiate and remove every component of galena Like iron is also part of galena, silver is also part of galena, manganese is also part. So you beneficiate, you remove all those unwanted metals, and then you'll be left with lead sulfide. Now it is this lead sulfide that you take to another industry, we call it processing plant, where they will apply what we call pyromethodological process to able to extract the pure lead. So you can see that industrial deposits they are not just metals. I can call it compounds. They are compounds on their own that have a commercial value. Thank you. Please, next slide. Okay, so you can see different types of industrial deposits, just as I said before: limestone, dolomite, clay, sand, even sand also is an industrial deposit. Gravel, feldspar, fluorspar, granite, and the case may be quartz, ginseng, barite, zeolite, barite, silica, and all that. They are also part of industrial mineral. Please, next slide. Next slide. All right, now let's go to the main focus of today's program, mineral testing technique. All right, and I'm going to bring this down because we have geologists on ground. We also have those that are not scientists. We have mineral people that are into trading, mineral trading. So I'm going to bring it down as simple as possible. All right, so there are important factors you need to consider when you are choosing an analytical technique as a chemist and also as a geologist. All right, they are important. These things are very important. You need to consider these 5 parameters when you want to analyze any mineral ore, or when you are sending your mineral ore for analysis as a geologist. Now, the first important one is that what are the specific elements that we are hoping for, or we are expecting to analyze? What are the specific elements that we are expecting to analyze? That is a very important thing, because to have an ore does not just simply mean that you just send it to analyze to the lab without having an idea of what the ore is all about. No, you must first of all try to have a rough idea of the specific elements. So what are the characteristics of these elements? Just before we started, I pointed you to a periodic table, all right? You also need to know the characteristics of that element based on the periodic table. And then what are the concentration of the element that we are dealing with? This is also very important. What are the concentrations? Now you have an ore as a geologist or as a chemist. What do you think? Let's assume that you want to check lead content in that ore. What do you think is the concentration of lead in that ore, even without analysis, even without testing it? You should have a rough idea, okay? Also, as a chemist, you should have a rough idea of the concentration of that element in that particular ore. Because if you don't have the knowledge or a rough knowledge of the concentration, you will use a wrong method and you have a wrong result. Just let's assume that you go to the site, maybe you're a geologist or you're a chemist, or you give you a sample, and you want to check lead in that sample. And let's assume that the concentration of lead in that sample is 0.001 ppm. Sorry, percentage rather, is 0.001 percentage. And then they bring the sample to you in a lab or as a geologist. You now went and used the XRF that is calibrated in ppm to check a lead content that is to percentage level. We will not have results. At the end of the day, you now write not detected, ND. But in the course of my analysis, I'll be able to find out that there is nothing like not detected. Not detected is only used when there is no right technique to be able to determine that particular metal concentration. Everything can be detected once you use the right tool and the right testing technique. So you need to know the concentration of the element. You don't need to know everything, just a rough concentration. Do we have this element in much quantity in this ore? Okay, from the physical behavior of the ore. Maybe, for example, look at malachite or of copper. Malachite is always green shade, so malachite ore. So you're able to ascertain the percentage concentration of that particular copper in that particular ore. So knowing the concentration of that element that you want to analyze is also a key factor in mineral testing techniques. And also, what mineral species are particular element associated? This one when we're talking about XRD. Which mineral phase does this element exist? For example, you are looking for calcium carbonate. Calcium carbonate exists in limestone, in the phase of limestone. So you need to also understand it. So we are going to, as we go down, you're able to appreciate all this I've listed out. As we go down, you're able to appreciate them and to